Hi and welcome to I'm building an AL compiler in AL. Hey, I'm Eric, and I'm going to show you today where I am in a, until this point, a very secret project. The only one who I think who know about it is my wife, but it has been like an evenings night project for the last 2 weeks, I guess, to build an AL compiler in AL. And why is perhaps the best question to start out with. I have found myself in a lot of cases actually wanting to be able to give my users, and that's a very broad definition, the opportunity to inject code into different operations. We have a project or product in eFocus called WSFN, which is a website tool where you can create websites with data and business logic from Business Central, and it has a small compiler built in, sort of PHP kind of style, but it has a compiler built in, but it's very primitive, pretty cool, but very primitive. And I've been thinking about how to take that product to the next level, and that would kind of evolve something more dynamic. Also with BCCL, I actually have a couple of cases with BCCL where it would be pretty cool to be able just to, inject code. And the last thing, not the last thing, but the thing I'm going to mention here is that I'm kind of missing the scratch pad experience we had with the Seaside, that you could actually type a couple of lines in a code unit, press Control R, it would run, and there were no deployments and nothing. It was very intuitive and very keeping the developers in a loop very small. That coupled with a long time interest in building compilers and working with that from all the way from back from university with compiler construction till when Microsoft released the source code to the Roslyn compiler, the compiler compiles C#, and the current AL compiler we have in Business Central is not a Roslyn compiler, because it's a Roslyn inspired, a based on some of the Roslyn code, but it's not a Roslyn language from that. So Microsoft can probably specify exactly what I mean, but there's a lot of concept in Roslyn that are different. Roslyn is pretty cool. So I was actually watching one of the Microsoft guys, the .NET guys who did a compiler, Imo Landworth, and he was also inspired by the Roslyn in the compiler he built, and I was thinking, maybe that's actually possible to do in AL. The first barrier we have is the fact that we have no object model. But if you remember my video on the JSON data types, I made the argument, and what's the timing here? That was a couple of weeks ago. I made the argument that the JSON object, JSON array, and so on could actually be used to create an object model. And yeah, you can. It's kind of weird, but it also works. So let me do a small demo, and then I'll kind of show you how this is put together. Just to be clear, that what I'm showing you now, I don't know where it's going. So this might end up in being a part of some commercial pieces of app software. This might be a tool sold by itself. This might be open source. This might disappear because I figure out that there's some thing that will never work, stuff like that. So you're getting a view into where I am at this point in time in this project, and I find it pretty cool, and I hope you're gonna enjoy it. So anyway, let me switch over to Business Central. We got it right here, and as you can see on the title of this page, that I'm not gonna brand this AL, because this will never be complete AL. I have no intent of this being complete AL, far from it. So it needs another name, and I start out just calling it a BC script, and then I started calling it mini AL, and then I called it embedded AL, and then upon with a minimal. Anyway, so let me know in the comments below what name you think is appropriate for this, and let me show you what I can do with it. So when it comes to compiling, when it comes to running code, there's kind of two groups of things, at least in the way I choose to describe it here. We have statements and we have expressions, and an expression is what you have in a lot of spots. Let me show here. Here is a great expression. So let's see if, can you see this? Is this big enough? Let me see if I can make it bigger. Oh, this is very big. This might just be breaking big. Well, I'm not able to scroll. Hey, I tried, guys. I really did. Here we go. This is kind of viewable. Anyway, so actually I need to, okay, this is the size it has to be, otherwise I can't see the box below. So I typed a 1. So this is an expression, meaning that if I want to evaluate the expression, I should hopefully get a 1. So I have here in the middle menu. Let me know in the comments below if you want to know how I created a menu in the middle of the screen. I hit the eval function, and you can see that I get a result saying 1. Okay, you're not impressed. Okay, let's keep going. So let's do 1 plus 2. That's also an expression. I do an eval again, and I got a 3. Well, now we're getting somewhere, right? So, but as you can see, I'm actually getting more than that. I'm actually getting a whole bunch of JSON. So that is because, as I said, I'm actually using JSON as the data model for this, meaning that my IL, intermediate language, assembly, whatever you want to call it, is expressed in JSON. And what I have here is I have an object called a binary expression syntax. So most of these names are directly copied from Roslyn, or at least inspired by Roslyn. So I have a binary expression syntax, and think about whenever we want to do something, we need to turn it in. Whenever we have, like, I can actually, let's make this even bigger. So I'll do 1 plus 2 plus 3 plus 5 plus 4. This will end up in a tree structure, meaning that we have a binary tree that expresses all the components, and they are linked together with operators. So in this case, our expression is, we have 4 nodes and 3 operators. So that means we have a binary expression where the left is another binary expression, and in that one the left leg is also a binary expression, And in that one, the left is a literal expression syntax that has the value 1 in it as a number token. I'll get back to these things in a second. And the operator here is a plus, and the right side is number 3. Hang on, Eric. 1 and 3, why are those together? And then they are in the other part of the binary tree, also added with the right side, which is the value 3, and the right side with the value 4. Did I say 2? I think I said wrong. 1 and 2. Anyway, so it kind of builds a tree structure with this. The cool part of this is this is a pretty easy 1 plus 2 plus 3 1 plus 2 plus 3 plus 4. That's easy. But what if we do 1 plus 2 times 3? Well, anybody who has been following along in math know that we have to multiply before we do the addition. So when we evaluate this, this is of course 7, because 2 times 3 is 6 plus the 1. Where if we wanted it to be 9, then we will need a parenthesis around this, and then now it's 9. Now we can see that we also here have a binary thing, but in the left leg of that is now a parenthesized expression. So as you can see, this is getting bigger and bigger and bigger as we make our expression longer and longer. And we could say plus random 99 like that, and we get something. So now we're calling a function inside our expression, but this is still an expression. The other part, as I told you, that though in my book, not in my book, that's the book. There's nothing about this in the book. In my mind, we have expressions and we have statements. So what is a statement? Well, a statement is like a standalone command of something. And let me grab, I got some totally random code here. Oops, so you can see that I'm declaring some global variables. I'm declaring a procedure called test. There's an if statement in here that will message test big, message test small. It will also call another procedure called test2, which is here. We got test2 has a vendor variable. We do a find first, and then we message the vendor name. And we have a test3 that takes a parameter and have a return value and times the parameter with 100 and return that. Then we have a begin end statement here that is not part of the procedure. So this is our main function, and it has, these are statements. So this is an assignment statement. I equal test3 times 3, and then customer dot find first, that's also a statement, and then another assignment and a modify. Test is calling the test function, and message is messaging out something just like kind of like message. But let's run this, and you can see that there were no messages but it's writing on the console. So what I have done is that I have actually this little fellow say, okay, I'm going to override my message function to write to a console rather than, if I run this again, we will get these things as messages. And now you can see in that case I put the JSON code for this in here. So those 30 lines of code is 1,000 lines of JSON. So and as you can see that this is this test program is a good indicator of the current state of whatever name this thing has. So we can do a lot of stuff. We can do database stuff. We can do procedures and goals and parameters and variables and if statements, and we can do repeats, and yeah, that actually it can do a lot. But let's go over to Visual Studio Code. So here's some of the code, and just to be clear that there's no trickery. There's no secret .NET components, or I'm reusing Microsoft DLLs or stuff like that. Target cloud. So this is pure AL, as pure AL can be. So when we talk about a compiler, what do we actually mean? So in this case, we're not compiling to machine language. We're not compiling to IL. We're compiling to some sort of intermediary state. And then we have an interpreter who can take that and execute it. But there are certain layers, and let me show the first layer here. So the lowest layer is what is known as a lexer. So the lexer, in this case, takes a text variable with the source and keeps track of where it is in it. Then we have a function called, so you can actually think about the lexer as, you know, a slicer. So what this thing will do, let me actually just scroll down and find a good example down here somewhere. So in case it reads a parentheses open, there's a, aha, I know this. So I will create a token that is just the parentheses open. This is an open parentheses token. If I meet the closed one, then I will say that this is a token that is a closed parentheses token. And that's kind of what's done for a lot of stuff. You can see the dot. So that's also a token, but let's go down here and see. So in this case, if we encounter a digit, we will call a function called read number, and this one will then read as long as is digit or dot, because it might be a integer, it might be a decimal. So in this case, we'll read until we don't have that anymore, and that becomes a token. Same thing with at some point we will, a underscore will trigger that we think that this is an identifier of some sort, and we'll go into read identifier keyword. And we, if this might be quoted, so there might be a double quote because that's the way L works, and then it will read digits also, because now we're triggered that we're kind of reading an identifier. So we do accept that an identifier has digits in it, but it cannot be the first character. So the lexer will chop off the source code. That was my Alexa. The lexer will chop the source codes into these tokens. So now that we have a stream of tokens, we feed them into what is known as the parser. And the parser, you see, calls the lexer. Actually, let me. So let's find a good example. Let's find a parse if statement. That's a good one. So in this case, this is the code that reads an if statement. So how's that? So we are triggered by the fact that we read if keyword. So actually, let me go back to the lecture for a second. Let's see if we can remember it was called read identifier or keyword. So what we have, and this is a true copy of how Roslyn did it. I have a code unit called syntax facts, and in here I have defined what are my keywords. So what are reserved words that has a special meaning in the code. So you cannot really create a variable called if, because that will just break. So these are the keywords. So they get their own token, a keyword token. So let's go back to. So what we can see here that if I'm passing a statement and I meet the if keyword token, then I know, aha, at the beginning of statement, if I find the if keyword, then this is an if statement. So I go in here. So I start by, then I have a function called match token that says, okay, grab the next. So this is a linear process that grabs the tokens out of the lecture one by one and figure out what to do with them. So in this case, match token. So give me the next token if it is the if keyword token. Then I ask to pass an expression, because if something expression-wise, let's go back here, and there were an if statement. If random 100 is larger than 50, this is an expression, just like we use random in the eval in the beginning. So we get and that as an expression, that entire tree of how big or small that is. And you can see that this is pass expression and it returns a condition. The condition happens to be a JSON object, because everything is an object. That's the object model. So it looks like everything is just JSON object, but in reality there are different types. I'll show you in a second. So then we want to match that after the expression we need the then. So then match token, so we get that. So after this we need a new statement, because then something. So that is the if it's true statement. So we pass a statement. That might be another if, and this is very recursive in that way. And then we pass a potential optional else. So let's say if it's if then begin. Well, the begin and end is actually a statement here, and then there's I call it in here, I call it block statement, and in the block statement you have multiple statements. So when all this has been parsed, I have 5 variables. I'm actually throwing keyword and then so the if, and then I'm throwing them out again because I'm not using it right now. So I have a code unit called if statement syntax. There's a function called new, takes the condition, the statement, and the else clause. So let's take a look at that. That actually creates and right now I have a code unit called the n object, which is, I don't know why it was called n, to be honest. So that one can create a new JSON object, and I add these I add the 3 structures as fields or elements in the object. I also tell what kind it is. So currently we cannot, there's no overload to add an enum to a JSON. So we do that through integers, meaning that if we go back and look what we had here, it says kind 303. global variables. So if I go into the syntax facts and find, syntax kind, where did that go? I think I put it somewhere else. Hang on, let's do something like this instead. There you go. So 303 was global variables. So this is now a JSON object, and an object in my world, and it has all the code, all the components for this if statement. That is added back into, in this case, a statement. So this is parse statement, and then that is in case of the global begin end, this is parsed here, and then everything goes back, and in the end we have something called the compilation unit, also Roslyn, that if we look at what's in a compilation unit, it's a list of members and the end of file token, just for good measure. And what kind of members can we have here? We can pass a member, and then a member can be a procedure, a member can be a variable declaration, or a member can be a statement. So the global statement. That's kind of the three things that we can put into to a compilation unit. So that's the parser, that's the second layer. So we have the chopper of the lecture, then we have the parser that kind of figures out what goes together and how is it organized. So we end up with this structure of the code. So in case of a real compiler, where you need to output an exe file or something like that, then you would start to take the structure that the parsers outputted and process that. You might have to run multiple passes through to figure out what types is correctly compared to anything, because at this point the parser has no idea if you're saying that date equal time. Has no idea. It can just see that, okay, you're assigning, here's an identifier and there's an assignment and something else, but it has no clue if what about types and so on. So then you will add another pass. What I have done here, saying that I'm not going to output something like that. So my third layer, let me close this down, and it's actually in right now one file. So bear with me. This is a code unit that's 1300 lines of code. Actually, that's kind of interesting. Let me show you. So right now, well, I got 3,371 lines of AL code for this entire thing, and there's only 99 lines of comments. Told you this is a midnight project. Forget about the JSON. The JSON is just the editor. The editor component. If you want to see a video on that piece, how to do a data editor component inside Business Central, let me know in comments also. Anyway, so that's the neighborhood of how many lines of code we have. So the interpreter is a third of it right now, and the interpreter is basically what's running this thing. So you pass it a unit, the compilation unit. There's a run unit, and it again, we're just using the JSON object as if they were objects, because they are in reality. It's just kind of a non-compiler forced way of looking at the member or the fields in the structure. But other than that, it's working fine. So the compiler unit, I'm just checking the time here, I'm not talking night. So in the compiler unit we had the members, so we start by for eaching through, so object.getArray, the unit and the members. So I made a bunch of helper functions to help the object kind of field, and I'm actually going to refactor a lot of this and go back and making even more helper function now that I kind of see all the places where I have done not so efficient things. Anyway, so we're looping through all the members and case the kind of members. So if it's a global variables, then we'll take this member, which is a list of global variables, and go and add them. So currently, present state, you can see that they're kind of so whatever this thing is named, remember, give me your suggestions. So right now we do text, date, time, int, decimal, booleans, and records. That's it right now. I'm working up courage to start with the options. Options are all the way back to the lecture to support the colon. So there's a bit of work in that one. So globals is a you can see that at the end we have a JSON object that's called global. So I just keep the globals in a JSON object. Procedures, again, they are added also to the globals because the name of the procedure takes up a spot. You cannot create a procedure on a variable that has the same name. So they're also added here. And then we have the global statement, and right now that's just kept in the loop because I have no idea the order of the members. Because in reality you could create the begin part at the top and then the global variables at the bottom, and all that works fine. So we just save it here and then we call run statement. And what do run statement do? Run statement looks at what kind of object is this. So you can see the get syntax kind. So always is looking to see, okay, I have an object now. What is it? In this case, if it's a block statement, meaning begin end with something in between, well, we will run through those. So those are an array, and we'll run. And actually, you can see we call the same function again. So we just call ourselves recursively with the new statement we have in here. The halt part is basically if you have an exit. So if there is the exit statement, then we need to stop doing stop executing as soon as we can. Another statement type could be an assignment, meaning variable colon equals something. There is the variant that this might be something that is dotted, so record dot field. So not dotted is easy. And here we can see that we get identifier. So if we take, like, go back to this one and find a simple, so this one, I equal something times something. So this is the identifier. This is the statement, and this is the expression. So in this case, we get the identifier that's I. So we find I in the globals. And if this is not a dotted global, then hey, we're good. Then we figure out what is the type of this. So type is so the type needs to be the same. So in this case, we know that I is an int. So we tell the evaluator that we're working with ints. So we start by ints. We can also let the evaluator figure out the type as it goes along. So in that case, we will not tell it the type to begin with, then we'll look at what type we're getting back from it. But in this case, we will get the type from the variable. Then we will evaluate the expression that is part of this assignment expression. So we get a value. In this case, value is a JSON value. So the JSON value can hold different types of values, which works very, very well. And so we get the value back, and we put the value back into the variable. Actually here I said variable, I didn't say globals, and I'm gonna show you in a minute. Actually, this is a bug here already, but I'm not gonna fix it right now. If it's a dot, it means record dot field. Then we need to figure out the field ref. So the challenge with records is that we cannot put a record into a JSON structure. So the globals cannot hold the record. The only structure in all of BC that can hold multiple record refs is an array. So somewhere down here we have an array. Right now I'm just saying 100, so don't make 101 variables right now. We had that, and then there are some structures around this to do easy lookups and find them. So now we get the type of the statement. We get that from the field. So we have a function that takes the type of the field ref and turn it into the evaluation type. And I'm not using field type internally. I use my own because I need to also have the unidentified type. So I need my own anyway. And then we evaluate, and then we need to put the value back into the record. This was an assignment :equal. So we use the as boolean, as text, as date on the JSON value to get the right one back in. It could also be that we want to call something. So now we're back in different types of statements. You can see that there are a bunch of them. So for statement, exit, repeat. I'm gonna stop talking right after this one. So maybe it's a function call, and function calls are complicated. If we go back to so I talk so much that it timed out. So if we go back to this, we can see that test is a function call. Message is also a function call. Find first is actually also a function call, but it's a dotted function call, just to make it a bit more complicated. So evaluate a function. Start by looking to see that if it's a dotted call, then hey, we need to get or reset calc something. Let's find an interesting one. So we need to do insert. Well, then we'll do an insert. We need to do a modify, then we'll do a modify, and then the rest of it is kind of get the variable, figure out that the return type is correct, and so on. So if we're using the modify inside an expression, well, it will only work if the expression is Boolean. So the type checker would make sure of that. So those are, you see, there's a bunch of dotted functions here. If it's not a dotted function, then we start by saying, do we have the name? Do we know the name as a global? Because if we know the name as a global, then it's a procedure. Well, it could be a procedure unless something is wrong. Well, we check that it is a procedure. And if it is a procedure, then we need to call that the statement in the procedure. But before we can do that, we need to prepare the world, because a procedure can have two things. And in my little example here, I have both. So this procedure has a variable, and this procedure has a parameter. So the variable and parameters becomes variables inside the procedure. So the first thing we do is actually that we take those things and push them on to the stack. And what is the stack? So the stack is a JSON array, and this array has, at the beginning, when you're in global, there's nothing. I don't want to support something that's not in AL now, where you have local procedures and so on. So I keep a separation between what's global and what's on the stack. So the stack is, whenever you make a call into a function, we put a stack frame on the stack, and that has the parameters and the variables, and potentially the return value. Right now I don't support named return values, but it's coming. So that is stack. So if you call another procedure, then you have another entry on the stack, and when you exit, then you pop the top of the stack. That's my dog going mad. That's okay. So we push the procedure on the stack. We run the statement, the body of the procedure, then we pop that procedure off the stack again. And if we have a return value, we grab the popped return value out of this. If it's not a global, then it's, if it's not a procedure, then it's a global scope function in BC, and I will show you one example, and then this video is getting too long. It's like random. We've used random a couple of times, so we just call random again. That's the beauty of implementing the language that we're writing this in, that all the functions are there. What's not the beauty is, let me show you format, because format is a beast. So what we have in, let me show you. If I do format here, we can see that we have a data type called Joker, but we don't have a data type called Joker because we cannot create a variable. If I create something here and say this needs to be a Joker, no. It actually kind of color it, but no, that's not a thing. So what we need to do is actually do a lot of case statements. So in this case, if we call format with just one parameter, the stuff that we need formatted, then I actually need to look at what is the type of that and pass the type into separate calls to format. So I need to pass a date into format if it's a date I have. And it gets even more complicated if we add actually, and I think there were a bug in the help text, because format number, that's an overload. That's an overload. There's no box here. So format string. So the third parameter can be either a int or a text, meaning that we start looking at, depending on the third, and this is zero index. So the third parameter, we figure out if this is a int or text, and then we need to call format with an int, as the third parameter, or we need to call format with a text as the third parameter. And we need to do that for all the combinations of the first parameter. So suddenly, with currently having 6 data types here that's supported, then it's 12 calls to format to cover all the cases. So that's kind of the quirks that I need to overcome here. Let me see, what else do we want to cover? I think you guys are probably done with listening to this. So yeah, one thing. So actually, you see the console here. So if we find message, well, the idea is simple here, that hey, if we do redirect to console, then we're just adding to a text thing here with string subs no. Same thing. Otherwise, we do a message. So quite easy to change how the inner things are working. The entire code can, of course, just be downloaded and loaded again. So this is not compiled, but this is at least prepared, parsed, lexed and parsed. So I haven't done that yet, but I want to do that. You can just load and run something that's pre-compiled, whatever we want to call it. So this is my little project. Let me know in the comments below if there's something specific that you want to see if I can do with this thing. If you have, and I know this is crazy late, 46 minutes into the video, that let me know if you have a need for this. Is there something that you can use for it? I'm totally gonna put it into the different cases I mentioned at the beginning at some point, unless I hit a major roadblock. But there might be a lot of other uses for this out there. I have no intent of this being complete. There's some of the data structures that are getting really, really hard to emulate dynamically, especially when it comes to arrays and the lists and dictionaries and stuff like that. That kind of hard to emulate. Perhaps we can do, but yeah. So let me know if you have use for it, and if you have that, then email me. Let me know if this is something that has your interest. Until then, and this is getting so late. So this is the compiler central in British Columbia, late night, signing off. Have a wonderful day, and I'll see you soon.